how it is useful and what it is actually exactly from a business, but as well from a technical perspective. Awesome. So let's start this. Today we'll cover MLOps. I'll deep dive a bit into what is it exactly, the type of use cases, the type of architecture, concretely what do we do in MLOps. I can take questions. All of you are technically on mute, so ask questions in the chat, and I'll be happy to address them during the call or after the call, after the talk. So obviously, I'll start first with an intro. So about myself and the company. So my name is Mohamed Sabri. I'm the founder and CEO of a company called Rocket Science. Rocket Science is a company headquartered is in Montreal. We're specialized in ML ops. That's pretty much what we do all day long. Myself, I've been in the field of data science for the last almost 10 years. Worked with different like companies, a lot of consulting and services involved in my career for large, medium, and small organizations. I've done at the beginning a lot of data. I moved from data analysis and data analytics to and BI to data science. And recently, in the last 4 years, it was more around like ML ops and everything from an ops perspective. As well, I teach during the weekend at the MIT. I'm a mentor and instructor there. I basically support people that are involved in a postgraduate program where basically we teach machine learning and pure data science. Always fun to teach and share what you know. I published as well a book. It's available on Amazon. It's called Data Scientist Pocket Guide. So on this one, what I wanted to do is basically create some sort of large dictionary that helps support data scientists on their day-to-day by providing concepts and explanation around those concepts. So I cover in the book, I think, over 600 concepts. Some of them are deep dives, others are maybe less, but the book is here to support data scientists, and it's available on Amazon. So I know we have a couple of teammates from Rocket Science on the call. So they might give me help regarding the question that you might guys have during the call. So I think we have Asim, who's like he called himself a rocket scientist. He's a machine learning engineer, works from data science, ML perspective, but as well some ops and software development. I think we have Asta as well on the call, who's a software, she's a software developer, Manu, software developer. And we have Mikhail, who's our project manager, recently hired. Yeah, I saw as well maybe Dimitro. Dimitro is a backend software developer. So what is MLOps? That's pretty much like, I think MLOps in the last 4 years have gained a lot of traction, but more, and a lot of it is a lot of buzz, honestly, because a lot of people, they call everything MLOps. Today, a customer, I'm like, we're doing MLOps. They're like, yeah, so you do ML. Yes and no, you know. So a lot of even ML stuff are qualified as ML ops. Any software or solution in the AI sphere is now called an ML ops tool. Um, some of it is just hype, and some of it is here basically as concrete support to the ops aspect. MLOps easiest definition, MLOps is just here to help manage the life cycle of machine learning. What does it mean? It means that it helps you basically create sustainable models within sustainable and scalable environments from the from the design development of the models until the production. So it's more like process focus, process in terms of technical process. What should I do when my model is ready? How can I send my model to production? How can I automate this pipeline? How can I automate the availability of this data? How can I scale this infrastructure? How can I deploy this model appropriately, respecting like production requirement? How can I integrate my model or my deployment with this system? All these are questions that we cover in ML and in ML ops. So its necessity is here basically, it's necessary because it's here to support you in the life cycle. So all the cycle that you have in the development, the production in machine learning, it's here basically to support you. A lot of it is around automation, and we'll discuss it a bit later, but automation plays a very important role in ML ops. So as you can see, based on the question I was asking, that actually belongs to MLOps, there is a lot of things that are not necessary just the deployment. And I think that's my next slide. It's the fact that MLOps is not just a matter of deployment of models. A lot of people, when I tell them that my company, Rocket Science, is doing MLOps, they think that all what we do is model deployment. Model deployment is a fraction of the work. We do cover so many aspects that are not necessarily visible from a first perspective, but are super important. A lot of time is being like, depending on, again, depending on the company, the use cases, but there are use cases where we spend so much time on the infrastructure. Let's say you're processing, I don't know, large IoT stream of data, and we need to make this data available in production for the model to score. We need to make this data available for the data scientists so they can develop. We need to potentially give access in a scalable way to GPUs and easy to access. So all these are more infrastructure question. When you have when you're building large models and you need like an appropriate infrastructure, how do you assess that? How do you manage that? As well, that's a part of the MLOps aspect. A lot of it as well is related to testing and debugging, and we'll discuss this aspect because there is something called CI/CD. CI/CD is the continuous integration and continuous delivery pipeline. Continuous integration, a lot of it is testing and debugging in a way that it's in an automated fashion. So when you create like your testing protocol for any code ML generated, you automate certain aspect of it. So basically, when a code is being pushed to a repo, there's gonna be an execution that will basically test this code. Okay, that's as well a part of the aspect. Everything data related, make data available in the development environment, make data available in the production environment as well. Those are very important aspects. And the automation, of course, that is very important here, where you wanna basically make the job of the data scientist easier, faster, and automated. And automation depends on basically the use cases you have, their nature, the availability of the people. I mean, if inside your company you have like I don't know, 3-4 data scientists and you have bunch of use cases in the backlog, well, it's better to have automation. I mean, all large tech companies that they have MLOps, and I know some of them, and I taught some of them, and they have a lot of automation from a CI/CD perspective, retraining pipeline perspective, data access, and so on. So that's for basically some of the aspects regarding like ML ops. Now how to compare it appropriately. I think doing a comparison between MLOps and DevOps is valid. Okay. As in MLOps, we do stuff that actually we do in DevOps as well, like continuous integration and continuous delivery. This is not a concept invented for MLOps. It's a concept that comes up from the development lifecycle management. Okay. And the CI, or continuous integration, is basically the ability to test, validate the code and its component, but also test and validate the data schema, and the models. So when the CI usually tend to act, when, for example, you create a code with couple of artifacts you need generated, some JSON files, and so on, your CI will basically act after you push your code. Okay, there will be like an automated execution that will take your code, do what we call unitary testing on it. Okay, will do any test case that is necessary. So basically it's testing your code. You want to make sure that the code that you pushed is potentially free of bugs, of problems, that input output scenarios have been taken in consideration, that all the necessary artifacts that you need to have there within your code are available in the appropriate format. Why is it so important in general? Is because you want to follow best practices in terms of development. That's what dev people, they do implement. So why not doing it as well in data science and in machine learning? That's pretty much like an important component and an important aspect to cover as well. I know it's not easy. That aspect is maybe not clear, especially if you're a data scientist, because you don't think like a developer. You think more like a researcher guy that tries to solve a problem using machine learning. But still, the way you need to work has still to follow the development like best practices. And then you have the continuous delivery. Continuous delivery is more about how to move from development to production, how to automate. Oops, someone unmuted himself. How to automate, for example, a pipeline, a data pipeline, or a machine learning pipeline. How to automate, for example, a model that goes from that is ready for production and push it directly as a new like available microservice or within like the deployment modules that you have. And some of it can be automated. Other aspects are not maybe that easy to automate, or we don't want to automate them. So that's for continuous delivery. So at the end, you deliver continuously to production. And then you have the continuous training, which is very specific to MLOps, where you tend to basically automatically recycle and serve your models. But usually I don't talk about continuous training because I believe that continuous training belongs to continuous delivery. So technically everything can be resumed in continuous integration and continuous delivery. And honestly, it's easy to talk about this, but today, we work with a bunch of companies, and these aspects, CI, CD, and so on, are not necessarily well mastered by AI and ML practices. I mean, for me, having a CI pipeline, whatever the size of your team, data science team, it's still important. Now you're going to ask me, yeah, but why should I create automation around unitary testing and test cases if we develop 2-3 applications or even one application in machine learning per year? It's still valid, because even if you develop one application, machine learning application per year, it's fine. Know why? Because think about it. When you develop something, you're going to iterate over it. You're going to resubmit, repush your code so many times. Like my team and I, we develop solutions in AI, ML, software engineering, ops, and a solution can be submitted and can be pushed at the end of the day many times with many updates, many patches, and everything. So each time you want to make sure that actually your code is following the best practices, that you don't have any indentation problem in your code if it's Python, that potentially you respect how you write the names of your classes and your methods, that input output is being validated and that there is no error generated out of it. that all the packages or dependencies that you have in your requirement.txt are actually valid as well, and so on. So all this is very important. That's for basically the CI/CD. Don't hesitate asking question on the chat if you have some. We can basically take the time to discuss them, as we don't have a big group, so I can take more time to answer the questions that you guys might have. So I would say when we work on an MLOps project with customers, between 60 and 70% of the time is spent on building an appropriate CI/CD. And like I said, in CI/CD, there are so much to do. The majority of it is around automation, automating like data, for example, validation, automating the input of your machine learning model, automating like the update of your feature store, and we'll talk about what is a feature store actually. So all these are different aspects that we see. I know you maybe, if you're a data scientist, you're not that much familiar with what is CI/CD, but get to learn it. The kind of tools that you see a lot to help you do CI/CD would be more around like Azure DevOps, for example, like Git Action, like what else? You have Jenkins. Argo as well can be good for that. So all these are tools, and usually you write large. The way you work it is you need to know the YAML language. The YAML language, because you're gonna write like large amount of code in YAML to run the automation. YAML is just like, let's say, how to compare it. I think you can compare it to bash scripting. You know, by then, before these tools, people used to go with bash scripting, and they'll create large bash script to basically do some automation and run automated command. Now you have YAMLs, and after your YAML will be executed by any of these tools that you have here. The type of architecture that you can have. One of the first thing we usually do in MLOps is you need to design an environment. Okay, designing your environment is very important. Okay, every environment with every company would be unique, because they don't have the same use cases, they don't have the same type of data, they don't have the same size of the team. I mean, a company that have 50 data scientists versus a company that have 2 data scientists on the same. Companies that deal with computer vision and images are not the same as companies that have the majority of their use cases marketing related. So it's different aspect that actually impacts at the end your architecture. But what you definitely need is always need a development environment. And a lot of the data science today is done locally, like locally on your laptop. I don't necessarily believe that that's the best solution. Okay, it's always good to have a development environment by investing in a development platform, can be open source or commercial. And there you would have the data scientist, and that's the beauty of it. You would have access to basically infrastructure as a service, depending on what you're trying to deal with. I mean, it's easy to deal with a large data set on a shared environment where you can potentially scale the resources versus doing it locally. Another aspect that we can discuss of it is a very important component is experiment tracking. Experiment tracking is super important because people, they sometimes think that the most important code in data science is the last one that I developed, the last one that I just created that should go to production. That's the most important one, and the rest, you know, is just experiment. I tried, didn't work, or I tried, it worked so. But the last one that is actually good, that is going to the production, that's the only code I want to say. No, that's not true. think about it as if you, in the word data scientist, there is the word scientist, okay? And that's the most important word. You're a scientist at the end of the day. A scientist, he takes notes of all his experiments, even the one that have failed. But still, those ones that have failed, he still have a tracking and a governance over the one that have failed. So he can track back and have access to the one that failed, even months or years after he finishes his project. And that's why having experiment tracking appropriate tool is very important. Because if you don't, first of all, within the same project, sometimes if you're a data scientist, you know it. Sometimes when you do experimentation, how many experimentation do you run? Sometimes it could go for one project, it could go over 100. 100 time you tried and tried and tried and tried different approaches, different model, different hyperparameters, and so on. But you need a tracking of all this. You need to, if I want to track back the experimentation 22 that I did 2 months ago versus the one that I did today, you need an experimentation tracking. The most popular tool that is open source available for that is called MLflow. It has been created by Databricks, and it's pretty smooth, pretty powerful. It does the job. There are others that exist like weights and biases. I think Comet ML as well, but those are commercials. And if you're on the cloud, like Azure ML have like experimentation tracking, SageMaker as well, and so on. So technically, there exist things to help you track your experimentation. And after everything from source coding and versioning has its importance, but that's pretty much like as this comes from like development best practices, software development best practices. All your code should be versioned, should be sourced in a certain way, and all the tag management that you need, because sometimes you push some code, but that's not the code you want it to go to production. Other time you push code and it's a tag for production, or it's a tag for a retraining pipeline, and so on. And your CI usually would intervene here, between the different experimentation you have done versus the code that you potentially want to push, or that you start wrapping up for going to production. And then there is another aspect. This is one of my big specialties. It's retraining pipelines. Okay, retraining pipelines are automated pipelines that you basically create and develop to make your life easier. Okay, why? Because you don't necessarily, each time that there is a need for retraining a model that went to production, you don't necessarily want to be, oh, I have to reopen my notebook, I have to rerun the model, and so on. Especially if in the pipeline the company has maybe 50, 100, or hundreds of models. It can be complex, can be complicated. Sometimes you just want to have like a ready to run pipeline that either you can trigger yourself, or that you can basically automate based on triggers, based on a schedule, or so on. Usually people, they see pipelines as static, but the strength of a pipeline in retraining is that you can have input parameters that you can inject in the pipeline. So potentially you can basically point to an S3 bucket before running the pipeline and change basically the directory to point to a new data set. Or you could basically, if you add a tag like XGBoost, you could basically decide, ask the pipeline to run just XGBoost model. That was already, of course, integrated within your code, and so on. So you have a lot of flexibility when you build your pipeline, and you have the ability to do pretty much what you want depending on what is needed. And the pipeline can be used not just for retraining a model, can be used for feature engineering. I've built pipelines just for feature engineering. You can that after feed a feature store, or you can create a pipeline that will do all the data engineering, and so on. So that's pretty much the strength of a pipeline here. You have all sort of tools that exist for that, again, like Kubeflow, Airflow. Those are more open source. Metaflow as well. As well, you can have more commercial solutions that are usually integrated within your ML platform at the end. Another aspect that is important in your architecture is model registry. Everything from a model registry is key here, because in a model registry, you will basically be able to register your model. This is like a, consider it as a catalog. It's a sort of catalog of machine learning models. It doesn't mean that it contains only models that will go to production, but it can basically contain all the models that were created, generated, even the one that didn't meet the required performance and so on. So it's good for tracking the assets and models generated. Usually here, for example, in a lot of cases, we build a model registry from scratch using a storage solution like Google Cloud Storage or S3 and so on. But you can use pre-built model registry, like MLflow have a model registry where you can basically push a model and then add a tag to that model. So basically will be a tag, could be dev, fail, experiment, staging, or production, and so on. And after everything from model serving. The model serving means basically the deployment of your model. That's the aspect that serve your model in production, so it can be basically integrated after with systems. In the last 5 years, 5 to 7 years, the concept of REST API and microservices have gained a lot of traction, and that's one of the most popular way of deploying. But we have to be realistic. REST API, microservices, these are very cool concepts. But in a lot of cases, and I see it in companies, model serving with the REST API is like a bazooka for killing a fly. Why? Because they rely on very old systems. Okay, so the system you might want to integrate to is an old system. Okay, it's an old system, old ERP. No one want to integrate with that. You don't want to touch that. So usually the integration and facing a REST API isn't necessarily the best choice. So, and that's why we have, even as an MLOps company, we have like a front end software developer that is, and she's very busy, just because the majority of the deployment will tend to be a standalone application. So we develop the front end. Why? Because the integration with the systems, no one want to do it. You don't want to do it because it's an old system. It will probably be an end of life in like 2-3 years. So what's the purpose of integrating with that? So in a lot of cases, it's either REST API microservices, but sometimes it will tend to be like more a standalone application that you want to develop. And another aspect that is important, it's everything from model observability and performance monitoring and management in production. That's where basically you want to track your model performance when it goes in production. Why? Because a model is like your yogurt at the end. You know, any yogurt, any food that you have in the fridge, it comes with basically consume before this date, because after this date the product is not good anymore, right? So what does it mean in terms of machine learning? Your model can lose performance in production, can suffer from drift. There are a lot of things. A model is not static, and its performance, it's not because you got in testing and during the development I don't know, an accuracy of 95%, that necessarily your model in production will stay with an accuracy of 95%. It's usually, first of all, it's not going to be 95%. It will be different in terms of performance. And the second, it might degrade in terms of performance. It might as well suffer from a drift. So that's why it's important to track your experimentation and be able track your performance, your model performance in production, and be able to have in real time a feed that tells you if your model is still performant or not. Us at Rocket Science, we developed a solution that is specialized in this, so it helps actually companies monitor machine learning models in production in real time. and it's open source. So we have a community edition that you can integrate to with your systems and so on. Any questions so far? Okay. So how to define an effective MLOps architecture? Based on what I saw so far is a piece of a potential architecture. There are so many things as well that you have to take in consideration. There are other features like pieces that I didn't talk about, like everything from uh, from all the access of the data, because we need data in production as well. In a lot of cases, you need data in production, not just production data, but as well static data, like for example, customer profiles. So how can I access this data? I need to make like uh, that data available in production as well. You have everything from a feature store. That's as well another important components and so on. Usually when we think architecture in MLOps, so you want to design an environment, usually I tend to ask this type of question to customers to define basically a potential architecture. It starts usually by asking around the MLOps expertise. What is the MLOps expertise that they have or they are willing to hire? Why? Because if you tend to have less expertise in house with that, okay, and you're not willing to hire, usually you want to go with you might tend to go with commercial solution that actually manage as much as they can the environment for you, the access to the infrastructure and everything, so you have less effort to put. That's where you hear about Azure ML, SageMaker, Equasio, Converge, Databricks. All these platforms are there basically to lower the MLOps effort, but still, and it's very important, no platform today does everything for you in terms of MLOps. Okay, you still need people to maintain this platform, provide do some automation on top of it and so on. So there is still work to do on top of that. The kind of inference is important depending on the type of data you have. If you're doing inference, meaning like in production, your model is being scored usually as batch processing against a database, well, that's a case. If you're more willing to do integration with live systems, that's another case. If it's live like scoring that you need over large ingestion amount of data, that's another case, and so on. So it's very important to know what type of inference we're looking for in general, in average. And the number of projects play a very important role, because depending on the size of the teams that you may have, short, mid, long term, depending on the number of projects, the choice and the decisions can be different. The automation level and the resource scalability is as well very important. In terms of automation, again, a team of 2 people doesn't require the same level of automation versus a team of 40, 50 people in data science. And keep in mind that the automation is here to avoid like repetitive tasks, okay, and allow you to scale in terms of resources. Because if you have, I don't know, if look, because the cycle of a data science project, you develop, you do research, you develop, after you push to production, and after you need to retrain, okay. But within these, there are steps that you have to add, which is the test cases, the unitary test, the validation of the model, and so on. So all this consumes resources, and even when the project is done and deployed, there is still time for need for maintenance, updates of the model, and so on. So when you have all this, can I scale my practice to 100 data scientists? Well, 100 data scientists, is it efficient regarding the number of use cases we have? Not necessarily, and that's why you need automation to make sure that you can scale your practice without necessarily having to hire half of the world to do your data science project and all the life cycle of it at the end. Another thing is, and that's pretty obvious, it's what type of suppliers does the company work with? I'll tell you why it's important. If your company is on AWS, okay, I'm not gonna offer them to do the platform on Azure and using Microsoft tools because they are already on AWS. So the easiest choice would be to go on SageMaker and have maybe SageMaker as one of the platform. So depending on what vendor they work with, if they are more open source shop, we had like unicorn companies as customers, and these guys are so funky because they want to develop from scratch everything. They come in, they're like, Mohammed, no limit, but we don't want to be locked down with Azure ML or whatever. We want the platform from scratch using open source stuff and pure code based. That's another level, and that's another requirement. But again, depending on the company culture and the company suppliers they work with and the cloud provider, the decision of the solution within the architecture can play a role. As well, everything from code development. Do you have a lot of citizen data scientists, or more like pure data scientists, or more data scientists with a software development background? Because if you guys have internally like more people that are like not really code people, they're not the best at coding, they don't follow necessary best practice in coding, and I don't know, they're new to data science. They're more like a citizen data scientist that use drag and drop solution and so on. Um, the approach is completely different here versus a company where they have data scientists with like extensive skills in software development and so on. So the approach would be different. You can't ask someone, a citizen data scientist, for example, to design unitary tests. I mean, just not in the skill range, and that's not necessarily the best approach for that specific team. Um, so the modern stack, I think everybody here have heard about Kubernetes, Docker. You know, I talked about as well REST API. All these are modern fashion of potentially deploying and working with assets, right? Not all company yet use these guys for that, but I mean, less and less people will use like a virtual machine to deploy a model. I still see it sometimes here and there. I find it funny, but it is less and less the case. The kind of project we've already done in the past was to modernize existing ML applications. With what? With containerization. Containerization is so powerful. And I'll give you an example that we've done. You come in, okay, there is an ML app, you know, a large application that runs, I don't know, runs recommendations for users on actions to do. And it's not a deployed app, it's more an ad hoc application that analysts, that data scientists run to provide results to the business lines. Let's call it like ML1.py. Okay, ML1.py have bunch of dependencies. It runs a pipeline side of it using a specific tool, and then I don't know, it has like couple of artifacts and some CSV file that actually you can update when you run the application. Basically, if you design that application on your laptop or anywhere, and me, for example, I want to download that application and I want to run it on my laptop, the installation and the setup of it to make it run will be painful, because you're the guy who developed it, his OS, his environment, and so on are not similar to mine. So at the end of the day, being able to share like that applications is just a painful process. So, and that's where containerization is like is so powerful, because if this app is being containerized, Okay, it can after run everywhere. I can run it on Mohamed laptop. We could deploy it on the cloud, and it will perfectly run because it's containerized. And that's the magic of containerization. It creates a universality after, and it will help you basically deploy whatever asset you have, whatever application you created everywhere. And we did a project on that, and it was super cool because the business impact was here. We were saving resource time, and the app itself was after deployed as a container on another pipeline on the cloud, which actually included like another level of automation. And I invite you, if you're not familiar with containers and Docker, to really deep dive a bit in it. It's very important concepts. Docker, like writing a Docker file, isn't the most complicated task at a basic level, of course. So it's the learning curve is not that really hard, but still there is like some knowledge and some digging that you would have to do. And in very specific complex cases of containerization, you'll see that sometimes it can get tricky, but still like it's definitely a great solution. And it make easy a lot of the deployment shareability process of everything you create. And I mean, Docker container, like on a day-to-day, like everything you use, a lot of things you use on the cloud runs already on container. I mean, any cloud provider, like they use Kubernetes for example, Gmail, right? Gmail runs with containers using like Kubernetes. So Gmail is just relying on large Kubernetes cluster for everything in term of Gmail system. One aspect that is important here to discuss is the technology and the tools. You guys will see it. There are so many technologies available on the market. Like it's just mind blowing. Technologies everywhere for everything. Like you have end-to-end platform. You could have bunch of CI/CD tools. You have as well tools for monitoring, tools for data validation, tools for this, tools for that. It's easy to get lost in this. I already told you the trick. See what is actually the actual company culture, what they're open to, what type of vendors you already have, and do an assessment. Just test the solutions and see which one fits you the best. And but don't lose too much time and don't get attached too much to the brands. I mean, at the end of the day, it's just like products. At the end, what matters is how they serve your technical purpose and how they help you create optimized environment. One cool thing we have done at Rocket Science is I'll go on our website. We did um, we did an assessment where we created a catalog. It's a free to use catalog. So a catalog that contains all the tools that you might be facing in MLOps. So it's tools, they are classified by categories from CI/CD, cron job, data catalog, data labeling, development environment, experimentation tracking, and so on. I can share with you the link in case you're looking for solutions. I think that's a good resource to have next to you. Um, all right, this is a great question. Is a data scientist trained to do MLOps? I think with the actual like state of the market, the answer is not always. Data scientists, they either in a company, they are the guys that do everything, because for a lot of company a data scientist he's in charge of all of it. I mean, from the development of the model to the deployment, he should take care of it. I see that even in medium-sized large organizations sometimes, especially medium-sized, they have 3 4 data scientists, and the data scientist does everything from data engineering to model development and model production, and usually they have to learn by themselves how to do the production, how to maintain their environment and everything. But still, I believe that a data scientist should contribute to the MLOps. He should contribute by providing best quality code, by creating his own unitary test, by developing test cases, by creating pipelines, ML and data pipelines, mainly ML pipelines. But for the rest, he needs support from either ML engineer, which is a new job that popped up in the last 3-4 years. And the ML engineer is there to create the ML solution. He can potentially help in development of a model, but he's there to deploy a model. So he's a bit more end-to-end than a data scientist. And of course, ML software engineers and MLOps engineers, they're more here to do the kind of stuff from automation, help to put in production, like create a cluster Kubernetes, deploy the apps on it. This is the kind of things like an MLOps engineer would tend to do. So a data scientist is not a jack of all trade. There are different profiles that exist depending on what is required and depending on the stage in the life cycle. So if you're a data scientist, sometimes you probably, especially in specific type of companies, you might feel that you guys are doing many things even outside of the scope of building an ML or analyzing the data. But technically, there should be complementary roles that actually support the data scientist in the process. But anyway, if you're a data scientist and you do everything, please contact me because that's a profile that is interesting for me. I don't call it data scientist, I call it more a machine learning engineer, and we look for that type of people to give us help within our projects. Now, another question. Is a DevOps trained to do MLOps? I hire DevOps, but there is a learning curve when it comes to ML. Of course, DevOps is as well a word that means everything. I mean, there are people, they're called DevOps, but they do bash scripting, and basically they're more sysadmin, like sysadmin, system administrator. Is not a DevOps. The DevOps that I tend to look for is more someone that works on modern stack, that does the automation. He's familiar with and very experienced with YAML language. He's done CI/CD, and he's good in sizing infrastructure and so on. That's the type of DevOps. But even there, they need like a learning curve because they need to learn the specificities of MLOps in terms of tooling, solutions, how we do things from an MLOps perspective. But there is still a learning curve, but the learning curve is less intense than for a data scientist to move on to MLOps. I already shared with you that resource, so you have access to that on the chat for basically helping you look at the different solutions that exist in terms of MLOps. Now a more let's say process business question. IT. Is IT owning the MLOps practice? MLOps is something very curious because everybody finds it cool. Everybody's talking about it right now, but no one inside the company want to take the lead of it. Everybody's like, oh, it should be the other one. When you talk to data science team, they're like, hey, it should be DevOps team. When you talk to DevOps team, they're like, ask IT. We don't have the bandwidth to deal with MLOps. So at the end, it circles back, and someone sacrifices to take the lead of it. In a lot of large organizations, MLOps usually is done by IT people. Sometimes it actually it is attached to the data science people. So it really depends. I believe that there is no perfect answer to this because when it falls under IT, it has usually to follow the speed of the IT culture, which is not always suitable to have fast deployment and fast creation of asset in terms of ML. But at least IT has budget, which is good. So when IT takes MLOps practice, they usually have budget to fund the practice and provide all the necessary resources or the necessary tools and so on. The kind of stuff we've done in MLOps, we worked with a fintech. It's a Mexican fintech, really cool people. We did with them the implementation of their first MLOps platform. We redesigned the architecture, helped them deploy the first use case, and we spent time working on the CI/CD. Really cool to see that we have a lot of international experience. It's very impressive to see that South America and Central America has a big maturity in AI and ML and development. They have very talented people, okay, in their country. And when I'm talking about country, I'm talking about Mexico, Colombia, Brazil, Chile. All these countries are great, and they have really astonishing talent with companies that are local companies that have implemented wow stuff in AI and ML. We worked as well with a US company called Take-Two Interactive, where we helped them modernize the stack of their ML and AI practice. That includes everything from Docker container and so on. So that's another use case where we intervene and work as well from our end. A complex use case worked on last year. This one was in partnership with NVIDIA, where the idea was to design a system that can do an inference of machine learning system over 450 petabyte of unstructured data. So basically, what you have to do is take models that have been designed and be able to implement those models in production, so they can start doing inference over a huge amount of data. Designing such a system requires deep infrastructure knowledge, okay, requires ML knowledge to understand if the model is fast enough in terms of inference. Everything from parallelization is very important as well. So all this make it like, that's the kind of use case that makes you very humble in your career and make you think that, oh, actually there are complex stuff here and there in the industry that actually is not just like I don't know, deploying a model in REST API, but something more complex that makes you think more and requires more in-depth knowledge in different aspects. Myself, if I did specialize in MLOps, because honestly, I was in data analysis at the beginning of my career, then moved to data science, then after MLOps. I think the problem with data science is a lot of it stays as a POC. A lot of those, oh, let's do a POC, but the most frustrating thing is, you're doing what you do to create value, but a POC doesn't create value. If you do a POC, it's cool, fine, good for you, but if it doesn't go to production, it doesn't bring much value to the business. And back then, it was 2017 or 18, 2018. Some customers were asking me, hey, Mohammed, can you, now that you've done the model, would you mind deploying it and, doing whatever you have to do to integrate it with our system? He's like, yeah, why not? If I can do it, I'll do it. And then I started that way. And after I realized that actually it is great. It is not as sexy as building a model, but it brings a lot of value. So that's pretty much like the idea behind me with MLOps. One thing as well that I can share with you is that we created a school. This school is called Data Scientist. And this school is available here in Canada and in US, but as well in Europe. So we have training programs in ML engineering. And this program helps you basically master everything from MLOps. And help you basically become a potential machine learning engineer. I'll share with you the course in case you have interest for that. Perfect. Now I think I can take the questions in case you have some, guys. Any question or comment? You can use the chat in case you have questions.